Today we're going to talk about loops. A loop is how you tell a program to do something over and over. Anytime you'd otherwise copy and paste the same lines with small changes or run through every element of an array one at a time, that's a loop. We'll start off with a for loop. A for loop runs a block of code once for each value in a sequence. The simplest way to get that sequence is the range function that we looked at before. So let me type out a piece of code and then we can talk about what I'm doing here. So all I've done here is I've written for I in the range 0 to 5, print out the value of I. So range 0 to 5 produces the numbers 0, 1, 2, 3, 4. The loop runs once for each of them, and each time through, the variable I holds the current value. That's why we see only values from 0 to 4. Notice that it stops at 4, not 5. Range goes up to but not including the second number. And this is the same rule that we saw in previous videos, like the NumPy video. Another thing to notice is the structure that we've looked at previously as well. The indentation decides the block of code. So underneath this for loop, all of the lines that are indented at this level will be considered part of that for loop. And so whatever's indented under the for runs every time through the loop. Now let's look at how we'll probably use for loops more often, using a for loop for indexing. Instead of looping over values directly, we'll use these values to loop over the index positions in an array and then reach into an array and use the values in that array. So here's an example. We're going to compute the kinetic energy of several objects from their mass and velocity using the formula half mv square. So we have two arrays here, mass and velocity. Each of them correspond to an object's mass and velocity, and they sit at the same position. I'm going to write some code first, and then we can talk about what we're doing. So let's walk through it. As I mentioned, mass and velocity are our two input arrays lined up so each object's mass and velocity sit at the same position. Then we make KE the array that will hold our answers. The loop runs I over the index positions, and here's the key. Each iteration, the same I indexes into both the input arrays to read a value and then into the output array to write a value. So mass of I and velocity I are the inputs read at position I, and then KEI is the output stored at the same position I. So position by position, I pulls a mass and velocity out, computes the energy, and puts the result back into the matching slot of KE. So looking at this term, which is len of mass, the len function gives you the number of elements in an array. So in this case, that's 5. So range 0 to len of mass produces 0, 1, 2, 3, 4, exactly the valid indices of the arrays that we have. So let's go back to a line that I skipped, which is this line. Before the loop, we create KE as an array of zeros, having the same shape as mass. This is called pre-allocation. So we set up an array before the loop starts filling it in. For NumPy arrays, this isn't optional. You need the array to already exist at the right size before you can start assigning values into it. NP zeros makes an array of zeros, and NP shape gives you the same shape as the variable that you give it, so mass. So KE comes out the right size to match. It's sometimes tempting to take a shortcut here, something like writing KE equals mass times 0 to get an array of zeros the same size. Don't do this. If your masses happen to be whole numbers, mass times 0 would give you an array of integer zeros, and then storing a decimal value into that would chop off the decimal part. So an energy of 2.5 would land as just 2. NP0s gives you a float, which is what you want for this kind of math. So make pre-allocating with NP0s a habit. So looking at our output, we ended up with 5 kinetic energy values that each correspond to the object that we have in our mass and velocity arrays. The last thing for loops is a nested loop. So that means a loop inside another loop. This is how you'll most likely work with 2-dimensional arrays. So a grid of values with rows and columns. So let's look at what we just did here. The outer loop, the first for loop, steps through the rows. So for each row, the inner loop steps all the way through the columns. So for row 0, we do columns 0, 1, 2. Then for row 1, we do columns 0, 1, 2, and so on. The inner loop finishes completely for every single step of the outer loop. And then we end up with a grid of values. Also, you can see it in the indentation. So there's 2 levels right now. The inner loop's body is indented under the inner for loop, which itself is indented under the outer for loop. Each level of nesting is another step of indentation. And then we printed out the grid, which gives you the values where you're multiplying the row times column. 2 keywords change how a loop runs, and we'll see them inside of an if usually. The first one is continue. It skips the rest of the current pass and jumps straight into the next one. It fits naturally into a for loop, so let's look at how you can use a continue to skip an iteration in a for loop. So let's look at what we just did. The if checks whether I is even, and that's what this percentile sign does. It gives the remainder of this expression, which is I divided by 2, and in this case, an even number will leave a 0. When I is even, the continue command is used to skip over that iteration and go to the next one. So only the odd numbers end up printing. So if I was 0, this would be true, and then you go through continue, then I would just increase to 1. 1 percentile 2 will give you 1, and so this condition is false, and then it'll print out 1, and so on. For each odd number between 0 to 9, this condition will return false, and then you print out all of the odd numbers. And for each even condition, it continues to the next iteration. Notice here we've used a lot of terms that we've previously talked about. We've used logical expressions, we've used relational operators, and so on. Okay, on to the next one. The next kind of loop that we're going to talk about is the while loop. The for loop is when you know how many times to repeat a certain block of code. The while loop is for when you don't. It keeps going as long as a condition stays true. So I have a super simple example of a while loop over here. We'll read this line of code as while I is less than 5, keep doing this. So there's 3 things to notice here. First, we set I to 0 before the loop starts. The condition checks I, so it already has to exist. I already has to exist. If you forget to initialize your I variable or whatever you're using here, the loop has nothing to check and it'll throw an error. The second one is something inside the loop has to change the condition. Here, I gets bumped to I plus 1 each pass. So eventually it reaches 5 and then the loop stops. If you leave this line out, you end up with an infinite loop where I stays at 0 forever. If I stays at 0 forever, this condition is true forever and the loop never ends. This is usually a bug and it'll hang your program. The third thing to notice here is the entire body under the while loop is indented. So whenever this condition is true, this block of code is going to keep running. And that's what we see in our output here. So we get values up to 5, not including 5. The last thing we're going to look at in this video is the break statement. Just like the continue statement that skips to the next iteration, a break statement can be used to leave a loop early, no matter what the condition says. So now I just told you that an always true condition is considered a bug. But paired with break, it can be useful in certain conditions. You deliberately write a loop that will run forever and break out of it when the right thing happens. So I did some stuff here. Let's go through it one after the other. The while true statement would loop forever on its own. The condition is literally always true. But each time through, we ask the user whether to keep going. Should we continue counting? And that's what this input statement asks. As long as they type anything other than n, the loop carries on. The moment they type the n, if catches it and the break statement fires and the loop ends. So that's what this does. We can do it again and it'll work no matter what input you give it because you're only checking whether the input is n. So if I say 8, yep, no matter what I give it, it's going to keep counting until I say n, and then we're out of the loop. This is exactly the situation this kind of setup is made for. You don't know in advance how many times the loop should run. That's up to the user. So you let it run indefinitely and use the break statement to end it when they tell you to stop. You'll see this structure often. Keep doing until the user decides they're done. So for versus while, which one do you reach for? Use a for loop when you know how many times to repeat. So every element of an array, a fixed number of steps, and so on. Use the while loop when you don't know the count in advance and you're waiting on a condition instead. Keep going until the user quits, until a value converges, until something changes. So let's do a quick recap of what we saw in this video. Loops run a block of code repeatedly. A for loop repeats a known number of times, and normally we'll write it as a for loop with indexing. So range of 0 to the length of an array to step through its positions, with the output array pre-allocated using NP zeros beforehand. A while loop repeats as long as a condition holds, so remember to initialize your counter beforehand and to change it inside the loop. Continue skips to the next iteration or the next pass. Break leaves the loop entirely. And nesting one loop inside the other is how you work across a 2D array or a grid of values. So that wraps up all of the core tools you'll probably use. And now you can write a real program from start to finish and over again.